Behold, fellow space enthusiasts, today we embark on a daring journey to uncover the secrets of one of the most enigmatic phenomena in our solar system, Jupiter's Great Red Spot. This mystery has puzzled astronomers for over 3.5 centuries, and the sheer size is enough to leave us all in awe. Imagine a storm so colossal that it could swallow up 3 entire Earths. But have you ever wondered what it's made of? How it's lasted this long? Welcome to Astropy. And join us as we delve into the depths of this tempestuous wonder. And maybe, just maybe, we'll unravel the mystery that has eluded us for centuries. Jupiter's Great Red Spot is a giant storm located in the planet's southern hemisphere. It's been observed for over 350 years, and it's so big that it could swallow up 3 Earths with room to spare. The storm is made up of swirling gas clouds that move in a counterclockwise direction. At the center of the storm is a region of high pressure that keeps it stable and prevents it from breaking apart. Scientists are still unsure about the exact cause of the red spot, but they believe that it's related to the planet's turbulent atmosphere. The rapid rotation of Jupiter creates powerful winds that whip around the planet, creating huge storms and vortices. The Great Red Spot is thought to have formed from one of these vortices, which gradually grew in size and intensity over time. The storm is fueled by the planet's internal heat, which drives the movement of gas and causes the swirling motion of the clouds. Over time, the Great Red Spot has become a stable feature of the planet's atmosphere, and it's likely to continue for many more years. One interesting theory about the information of the Great Red Spot is that it was caused by a collision between 2 smaller storms on the planet's surface. The collision would have created a disturbance in the atmosphere, which could have triggered the formation of the larger storm. However, there's not enough evidence to confirm this theory. Over the years, scientists have used telescopes and spacecraft to study the Great Red Spot in more detail. One of the most interesting findings is that the storm is changing over time. It used to be much larger than it is now, and it has been gradually shrinking over the past few decades. Scientists are still trying to figure out why this is happening, but they believe that it may be related to changes in the planet's atmosphere. Another interesting finding is that the Great Red Spot is not just a visual phenomenon. It also affects the planet's weather and climate. The storm is so massive that it creates its own high-pressure system, which affects the surrounding weather patterns. It's also thought to play a role in the formation of other storms and vortices on the planet. Scientists have also discovered that the Great Red Spot is not just a single storm. It's actually made up of smaller storms and vortices that are constantly interacting with each other. These interactions create complex patterns of motion and turbulence that are still not fully understood. In recent years, spacecraft have provided us with unprecedented views of the Great Red Spot. In 1979, the Voyager 1 spacecraft flew by Jupiter and captured stunning images of the storm. In 1995, the Galileo spacecraft arrived at Jupiter and conducted extensive studies of the planet and its moons. More recently, NASA's Juno spacecraft has been orbiting Jupiter since 2016 and has provided us with even more detailed images and data. Juno's instruments have allowed scientists to study the storm's internal structure and dynamics, as well as its interaction with Jupiter's atmosphere. One of the most surprising findings from Juno's observations is that the Great Red Spot is not just a static feature. It's a dynamic system that's constantly evolving and changing. The storm's not perfectly symmetrical, and its shape and size can vary over time. Scientists have observed changes in the color, shape, and intensity of the storm, which suggests that it's responding to changes in the planet's atmosphere. Juno has also provided new insights into the temperature and composition of the Great Red Spot. The spacecraft's instruments have detected higher temperatures and more ammonia in the storm's center than in its surroundings. These observations suggest that the storm may be drawing material up from deeper layers of Jupiter's atmosphere. Indeed, despite decades of observations and numerous spacecraft missions, there's still much that remains unknown about the Great Red Spot. One of the most puzzling questions that scientists have been trying to answer is what keeps the storm going for so long. Most storms on Earth typically lasts for, a few days, few weeks at most. Well, the Great Red Spot has been raging for over 3 centuries. One theory is that the storm is being sustained by Jupiter's internal heat. Jupiter is a gas giant, which means that its interior is mostly composed of gas, with a small rocky core at the center. As the planet rotates, it generates heat through a process known as differential rotation, which causes the layers of gas to move at different speeds. This creates a lot of turbulence in the planet's atmosphere, which can lead to the formation of storms like the Great Red Spot. Hey, thank you for joining us on this fascinating journey through the mysteries and wonders of Jupiter's Great Red Spot. We hope that you found this video informative and entertaining, and that it inspired you to learn more about this incredible phenomena that exists in our universe. So keep looking up at the stars and keep dreaming about the wonders that lie beyond our planet. And remember, the universe is vast and full of mysteries, but with curiosity, determination, and a spirit of adventure, anything is possible. Thank you, and until next time, keep scrolling for more videos on our channel.